Good morning, good morning. We're a few minutes from starting. People are logging on right now as we speak. Super excited to be here with you guys this morning. So we'll give it a couple more minutes. There's over 100 people signed up for this webinar this morning, so super appreciative of that on this beautiful Thursday morning. So technically, like I said, should be over 100 people. So I'm gonna wait a couple more minutes before we get started, and we'll get rolling. Lots of people are signing up in the last couple minutes. So once again, we'll wait a couple minutes. We'll get going. I think it's pretty much it. Yeah, one more minute. Lots of people are logging on right now as we speak. So I'll wait another minute or so, and then we'll start. Okay, let's get this show on the road as people keep logging on. For those of you that don't know me, my name is Andre Rioux with Acoustic Tech. I suspect that lots of you have actually attended one of our webinars. This is the fourth of our series, and then obviously we appreciate you attending the webinars. Like I said, there's over 100 people signed up for it this morning. I'm particularly happy to be here with you this morning because it happens that got a power outage at my house last night, and until about 30 minutes ago I had no internet. So you can only imagine, to some extent, the stress level that comes with that. But people reacted quickly, and then here I am. So once again, appreciate you making the time to attend this webinar this morning. We'll definitely keep it within an hour, maybe even a little bit less. Just for those of you, especially on the island, so in British Columbia on the island, ultimately the idea with talking about alternative ways, and then I'm super excited to be talking to you guys about this morning and throw some ideas at you. Originally, I was supposed to schedule that physically in Alberta and the territories I personally deal with, and obviously I have my whole team behind me that was going to do the same, but obviously with everything happening, we switched to an online platform, but I tried to build this next hour to be as efficient and as informative as possible. So hopefully you guys will pick up a few things and get some ideas, and it goes without saying that we can certainly be in touch after the fact. The webinar is also recorded, so for those of you that need to leave a little bit earlier or that couldn't make it, obviously I assume those that couldn't make it are not hearing me right now, so you're still going to get the recording by email. So why at the beginning we wanted to talk about alternative ways. Couple things. As you know, acoustics has become, especially for multifamily, multi-story, has become a big deal, especially the past few years. Expectations of condo buyers or people that lease the space has drastically increased. People are more knowledgeable than ever, and then they expect more peace and quiet. There's also been drastic changes within the code example, the weight, not only on the acoustic side, which has impacted architects and builders for sure. So the idea today is to throw some innovation at you. And quick story I want to tell you is I was in touch with someone from Vancouver a couple days ago, and we were talking about the webinar, and that person's actually on the call right now. And one of the things that kind of fazed me is that person said to me, Andre, I was having a conversation with my father, which has been in the industry, in the construction industry for forever. And then when he was talking about innovative ways to do things, which we'll obviously talk about today, the answer of his father was, yeah, son, we've been doing this for 35 years or 40 years this way. And then the son replied to his father, that may mean that you've been doing things wrong for 35 years. So to some extent, we're going to be, and I thought I chuckled with that because to some extent it's entirely true. It doesn't mean because we've been doing things for 30 years or 40 years that ultimately there's not new ways to do things. So I would assume that none of you are watching movies with a VHS recorder at home. So innovation, technology evolves, and the idea this morning is to throw some things at you that you may not have ever seen. So for some of you that have attended the webinars before, I still want to take some time to talk about the principles in that regard. So we're going to be talking about code requirements. So it's going to be a little repetitive, but I don't want to take too much time on that. I want to talk to you about the principles for two reasons. First, it's important to put that in perspective to when I'm going to be talking about different assembly options. And also some of you have not attended the webinars that we offered before. So I'll go quick on these sections here, but I want to spend the core of our time on alternative ways and some assembly options, and to some extent throw some ideas at you. Okay. Who is AcoustiTECH? Extremely briefly, AcoustiTECH. We've been doing acoustics for over 20 years. We worked on well over exceeding 20 million square feet. Actually 100 million square feet of multifamily we've worked on. And we do this by offering guidance and solutions to people that are frustrated with a few things. Acoustic complaints or lawsuits, whether it's happening or we don't want it to happen. So property management companies, condo boards, architects, builders, obviously contractors, anybody that would be concerned, with potential acoustic complaints or lawsuits or dealing with them currently. Customers' negative perception of a building, that cannot apply more to what we're going to be talking about today, especially with the wood frame buildings. So obviously, we're going to be focusing mainly on that. So, wood frame buildings out there, and I've been doing this long enough to know that often like potential buyers will be more skeptical when it's a wood frame building because they're under the impression that it's not going to be as good acoustically. Well, there's no reason for that anymore. There's new ways to do things that ultimately those buildings can easily compete against concrete buildings or even steel structures. New code regulations, each territory, the US and Canada is a little bit different, but there's no doubt that there's code changes that affect what we're trying to do on a day in, day out basis, aside from the expectations. Also, abundance of products and misguided information. AcoustiTECH spends a great deal of energy, time, and money into educating as many people as we can on the misguided information that's out there. A lot of people cut corners. A lot of people publish ratings associated with their products, which are very misleading. And then ultimately what we do and why we're doing this is try to cut right through this. So ultimately, I'm going to touch a little bit on that throughout the presentation. Again, we can also do that ourselves, AcoustiTECH as a company, but we're also fortunate enough to be able to count on our partners. So under the AcoustiTECH umbrella, you've got Suprema, which is a gigantic company for building envelope. I'm sure you guys are aware of who they are. Same thing with Firmacell, which is a James Hardy division. And then we work with a lot of local acoustic engineers. And then also one of them out east that's done a great work with us called Acoustics that was actually sitting on the webinar last week on mass timber. So again, the point of that is we are ourselves experts in this field, but we also surround ourselves with a lot of people that have a lot of background and data, which allows us to bring a lot of that expertise to your doorstep. Let's get right into it on the building code. Very briefly, there's two types of noises. There's the STC, which stands for sound transmission class, and there's the IIC. Sound transmission class is everything not in contact with the structure, being voices, television, radio, and such. It's all direction within a building, so it can come from the unit below and travel upstairs, side by side. So anything not in contact with the structure. The code in Canada does require a 55 or an ASTC, stands for apparent. So basically the idea is it's kind of the new field test, should I say. So it's taken into consideration that the environment in which we're doing a test is not perfect. So it takes into consideration that the sound may travel through the walls and this and that. So to some extent, the difference STC, ASTC would be in a nutshell like comparing a car consumption for gas of a highway driver and then city driving. So to some extent, that number is not exactly the same because it's not the same conditions. Recommended minimum in Canada for the STC is 55. So did I say 55 a little bit earlier? I apologize. The minimum required STC is 50. The minimum ASTC is 47, and the recommended minimum of the code is 55. I apologize, I've done this way too many times. A little bit of a brain here. In the US, the STC requires 50 and the ASTC is 45. When we go to IIC, the IIC is a different animal altogether. Very important to understand this. In Canada, there's no requirement for IIC. There's no requirement for AIIC either for impact insulation class, and impact noise being anything in contact with the structure. So footfall, so people walking, running, kids playing with toys, moving furniture, dropping objects. So anything in contact physically with the structure is considered an IIC. And like I said, it's not required in the code. In the US, it is required. It needs to be 50, and the minimum AIIC is 45. But the recommendation in Canada is the same as STC. It's also 55. So here's what happens. In our world, it gets neglected. It gets neglected a lot. It gets neglected too much. So all of a sudden what happens is a building, a lot of time and money to some extent gets invested into doing an okay job or a good job on the STC, but then the IIC gets basically left behind. But ironically, Mr. and Mrs. Smith that lease or buy a condo somewhere, they don't know what the code says. And to be frank, I don't think they care. So what happens is the property management companies or even the builder themselves end up with dealing with the aftermath of a building that was designed, with an okay or good STC, but then on the IIC, we're falling short. So we end up with a lot of complaints. And in our world, the percentage of complaints, and then that's from 20 years of doing this, is well over 80% that comes from the IIC. So what is that telling us? It's telling us that despite the fact that it's not in the code, we should probably not neglect it. So very important anytime we work on any design, anytime somebody reaches out to deal with us, have you thought or are you considering doing something specific for the IIC? Because naturally people will say, I just want to be over code or I want to be XYZ on STC, but sometimes they don't talk about the IIC. So bottom line is, let's try not to neglect it because it is creating a lot of hassle, which is a lot harder to fix after the fact. The other thing we need to understand too is how it actually works. So if you look at the picture on the left side, you'll see a tapping machine. That tapping machine is installed over top of floor. There's a microphone, a receiving machine in the unit below. IIC is only top to bottom, so only one direction, because obviously the vibration can only go down if all of a sudden we're walking on that floor. What are we actually testing when we're measuring an IIC? Well, I'll tell you what we're not testing. We're not testing a product. So we spent a great deal of time explaining to people that you cannot associate a rating to a product. So those of you that think that it's okay to either ask or that you're going to be in good shape if your underlayment underneath the floor to some extent is claiming a 72 IIC, well, I can tell you right now that unless you understand where that underlayment was tested and with what, it's impossible to really know whether you're actually going to end up at 72. So I can tell you that 99% of the time, if you're using hard surface flooring on an underlayment, just to use that as an example, you will not be near the 72 IIC you think you have, because there's most likely not going to be any sealing if, for example, you're on a concrete slab. So every component within that assembly is what's going to dictate what the assembly is. So you cannot associate a rating to a product. You have to associate a rating to an assembly. So we always need to know how it was tested, with what environment, what structure, what's the floor, what's the ceiling composition, if there's any. So I know that I've hit that nail on the head multiple times for those of you that have attended the other webinars, but I think it's extremely important to understand. Acoustic principles, every building performs differently. It's not only a matter of understanding what to do with the STC and IIC, but what's going to be very important even for this particular webinar with the alternative ways is to understand that each building, each structure, each material will also perform a different way on high frequencies or low frequency. For example, if ultimately you have a very heavy building, you may not be prone to transferring as much of the footfall on the low frequency, but you will on the high frequency. So understanding that each building in nature is going to be different is going to be key, because in a nutshell, you're able to navigate through what that structure is capable of. What do we need to pay attention to? What is that building or structure going to be more prone to transferring STC, IIC, low frequency, high frequency? Once you start navigating through this, we can do incredible things. And we can also, in some cases, avoid mistakes or even save money, because it would be irrelevant to try to control the low frequency if it's already controlled by something else, where we're going to be lacking in the high frequency. So the idea is not that we've become, or that we're going to become acoustic engineers this morning by any stretch, but at the end of the day, if you surround yourself with people that know how to navigate through this, you'd be amazed what we actually can accomplish. So AcoustiTECH, that's what we take pride in doing day in, day out, and to be honest, whether it's me or my team, we enjoy every second of it. So it's things that we navigate through every day that we're quite knowledgeable about. Acoustic principles, once again, very important to set the table for the rest of the presentation. 5 principles are super important, mainly on wood frame buildings: the presence of mass, the presence of resilience and decoupling, void treatment, sealing, and flanking. So I'll touch on those very quickly. What does mass do? Mass, in a nutshell, basically is going to do 2 things. More mass and density you got, better you're going to be on STC. So ultimately, if for example, my doors to my office closed, when ultimately if somebody would be to play in the kitchen, well, they wouldn't hear my voice as much, because I'm introducing mass between people's ears and my voice. So that's why sometimes the structure, or wood frame structures, will use concrete or gypcrete as an example, is to help with that STC. The other thing that mass is going to do is flanking. Heavier a structure is, less it's going to tend to bend or vibrate when you introduce it to energy. Single homes are extremely noisy in the basement, and the main reason for that is because everything is super light. So when you have a hardwood floor, or whatever it may be, or even carpet, over top plywood, over top joists, a little insulation, and then you got 1 layer drywall, it's so light that when you walk on it, everything bends, and then ultimately you can hear the vibration of the squeaking downstairs. So we always need to remember that some mass is going to be important for STC and flanking. The other principle that's neglected a lot within the new construction business or even retrofit is the presence of resilience and decoupling. What this basically means is that if things would not be touching each other on the IIC, because the IIC requires a physical contact, it requires a physical bridge. So if you require a physical bridge, well, ultimately, the vibration, if you don't give it that bridge, well, it's not going to have anywhere to go. So I want you to imagine the best way to illustrate this would be if ultimately you have, for example, a hard surface floor on whatever substrate you want, and that floor is levitating from the substrate. You understand that if you walk on it or run on it or dance on it, the vibration is not going to naturally jump to the substrate. It's impossible. It would on the STC because STC does not require physical contact. But the IIC in this case works exactly the same within thermal, where if you look at a source of heat and you don't actually create contact, you're going to feel the heat and you're not going to burn your hand. But same thing with electricity. If you look at a naked wire on the wall, if you don't ground it and create physical contact, then ultimately you're not going to get electrocuted. So bottom line, IIC works a little bit in the opposite direction than mass, which means that ultimately mass does a good job with the STC and flanking, and resilience to some extent, denser a material is, faster that vibration is going to tend to travel through it. So if we combine mass and resilience, meaning we have some mass, but then we also have things not touching each other, we end up in incredible places. So applying this principle has basically saved the day and has actually currently taking buildings that were used to be in the high 40s on the IIC and catapulted them to the high 50s, low 60, just by introducing different ways to do things. Okay. Void treatment, very important. Basically, in a nutshell, it's the idea of bad insulation or insulation. So the more the better within the ceiling. Ceiling, in this case, wherever air can pass, so can sound. So always when you look at your design, butt lights, openings, vents, so anywhere there's a gap of air underneath the door, whatever it may be, the assembly, the wall assembly, the ceiling assembly, floor assembly is going to be as good as its weakest link. So to some extent, keep that in mind. Sometimes that's why it's super noisy when you're in a hotel room, and then they could say all day long their doors are acoustics, but if there's an inch of air underneath the door, you hear everything that's going on. It's because that sound is going to find the weakest link and then basically make it to your room. Flanking, very related to resilience and decoupling. In a nutshell, it's the concept of things not touching each other. So it's one of the reasons, to some extent, we say don't put the floor covering directly on the baseboard, so you're not creating a bridge that's going to ultimately make it to the structure and go downstairs. So those are the principles that I want us to keep in mind as we're designing things, as we're making decisions. Now we're going to get to some extent to the core of the actual assemblies. Can wood frame structures be more efficient than concrete ones? Well, if you asked somebody 20 years ago, they would have probably said absolutely not, because one of the principles that they were understanding is more mass the better. But a concrete topping or gypcrete or at the end of the day, it doesn't necessarily save the day on everything. So if we combine STC, IIC, low and high frequency, we can do incredible things. What's the advantage of wood frame buildings versus concrete ones? Well, there's a lot more components to play with. So because we have so many components to play with, that means that we can basically apply the principles we just learned a lot more than a concrete structure, because a concrete structure, in a nutshell, has got 3 components: a floor, an underlay, and a concrete slab. So ultimately, when you look at a wood frame thing, you can play with the components to achieve a certain goal and basically get in a better place. So example, we've worked on multiple buildings, especially I personally take care of Western Canada. My colleagues take care of other territories, but it's usually pretty much the same. Wood frame buildings are usually in the high 40s on the IIC to the beginning of the 50s, where the building code recommends 55. In those ranges, no doubt the phone's going to ring a little bit. There's going to be some complaints. So I'm still to meet one developer that tells me, Andre, I don't ever deal with acoustic complaints. So there's obviously a problem. There's obviously frustration that comes with that. What can we do? So even though I have nothing against a wood frame building using concrete topping or gypcrete whatsoever. As a matter of fact, we've worked with multiple builders that use that particular assembly. Sometimes you want to use concrete or gypcrete because you have heated floors. In some cases, on mass timber, as an example, if you're over 6-story for fire, you technically have to use a topping. So I have nothing personally against the concrete or gypcrete. There's crazy, amazing things we can do with those buildings, as you can basically see with the numbers on the right side. So we can basically go from 47, and then by introducing different decoupling agents, which we'll touch on in a minute, we can make it to the 60s on the IIC, which, by the way, in most cases is going to be more performant, more efficient in concrete structures. So, you know, for the wood frame builders out there, just know there's hope and there's ways to do things. Now, let's get to the actual core of what we wanted to talk about. What I just showed you is what we typically have seen for years. Not as much on the right side, not as much basically on the boosted up assembly, but this is what typically has been done with frame buildings for 20, 30 years. Now, because of the code change, because of weight restrictions, sometimes people have to put a little bit more weight in the shear wall. Now we're stuck. What do we do if we cannot use a topping? What do we do if we want to get rid of the topping? And what would be the advantages of doing that? The advantages of not having concrete within your building, there's a ton of advantages. And ultimately, it's not a matter of you should do that. It's a matter of, hey, now you have options to evaluate whether that speaks to you or not. But I can tell you from having played with this for years now, that I deal with a lot of people, whether they have to go away from the topping. There's a lot of people that even before they had to get away from the topping, they said, hey, is there different ways to do this? Because there's downsides to doing it the same way I've been doing it for 20 years. Like I said, weight and then acoustic being only two of the reasons. So what are the other advantages? Sequencing. Keep in mind that when you're doing a topping, depending on the season, if it's winter, if it's summer, depending on the schedule of the actual contractor you're dealing with, if there's only one contractor in town, you might be 6 months backed up. It goes without saying too that if all of a sudden you got to pour a topping on your building and you have to wait that it dries, you've got to clear the whole floor. So there's a lot of advantages with sequencing that using alternative options will be a lot quicker, and you don't necessarily need to wait for anything because it is a dry topping option. Weight, we'll touch on that in a minute. Substantial saving on weight. We're currently working on multiple buildings, especially on the Victoria Island, where the seismic provision in the code has really messed up with what people are trying to do. But in my opinion, it might be a good thing. But then to some extent, people are a little lost, or at least don't know really what their options are, because you don't want to get rid of the topping and not pay attention to what it's going to do on acoustics for all the reasons we've talked about before. So saving weight has a lot of advantages, a lot of things you can all of a sudden do, not only on the seismic side of things, but also there's people that want to get rid of the weight because they could do more on the exterior of the building. So it opens up all kinds of opportunities. Easy and quick installation, no drying time, no humidity in the building, which is often problematic. No self-leveler, so nothing is perfect out there, and ultimately sometimes people have to come back to meet the flooring criteria for leveling and such. So those are only a few of the advantages that we can that these options or these assemblies I'm about to show you can solve. There's one more that I did not write down because I didn't know how to write it down. But in pardon my French, I have builders that I work with that say to me, I just don't want to use a topping, it's a pain. So I didn't know how to write that, but there's a lot of builders that, cost aside, they just don't want to do it because it's part of all of this, but there's also for them, hey, let's be innovative, let's find ways to do it a little bit differently, even for the environment. I got people talking about for the environment, for hey, if something happens, I want to change the floor, whatever it may be. So there's a lot of advantages that way too. So let's get right into it. So the first assembly I want to talk to you guys about is the combination of Suprema Acoustiboard and Suprema AcoustiVibe. Suprema AcoustiBoard, bear with me here, I'm going to move my little thing so I can see. So Suprema AcoustiBoard, in a nutshell, is a panel 3/8 of an inch thick that's designed to replace a concrete topping or gypcrete in a light wood frame situation. So it's made of recycled rubber and synthetic fiber. There's a key to that is the panel itself, which I'm going to show you. So the key, the panel itself is this thick. Bear with me here. I was going to show it to actually my speaker, so go figure. So the AcoustiBoard is basically a panel 3/8 thick, hard rubber core, rubber granules underneath, so less contact with the substrate for resilience and decoupling reasons, and the fiber over top is designed to be a little bit more efficient on the high frequency. So within that panel, you end up with some weight, which by the way is 1.7 pounds per square foot versus the typical, let's call it 18 to 20 pounds a square foot for a topping. So it's substantially lighter than using a concrete or gypcrete topping. And it comes at a 3x4 feet sheet, so 12 square feet. The key to this is, and I'll show you an installation video of it so you can visualize it, but the bottom line, that's what it was designed to do. It's designed to be floated over top your plywood. One quick note about AcoustiBoard. AcoustiBoard is only permissive with floated. In some cases, we could glue down engineered hardwood to it, but it's only designed to be used with a floated engineered hardwood or floated laminate floor. So you cannot put LVT or tile directly over top of it. I'll show you something else that we can do. So what we usually do for tile, if for example you have a laminate floor or engineered floated, what we do for tile is wherever the floated laminate floated engineer will be, we'll install this, and then wherever the tile is going to go, we're going to double up plywood to match the height. We're going to put another kind of underlayment over top, possibly Suprema Sopra way, or for example AcoustiTECH ceramic, depending on the situation. And then we're going to put the ceramic tile. So now you're adding the mass that you need because you got rid of the topping, and then we're still decoupling with an underlay, and then with the right underlay, and then you put your tile. So everything's flush, and then acoustically speaking, we're in a heck of a good place. One other thing I want to talk about, the AcoustiBoard AcoustiVibe. The reason I'm talking about AcoustiBoard AcoustiVibe is because they go hand in hand together. Acoustic Tech is not crazy enough, pardon my French again, to go to market and just say, get rid of all that weight, use AcoustiBoard on its own. Challenge with that is if you do that and you're not controlling the flanking that's going to happen from getting rid of all that weight, well, then technically you're creating a problem somewhere else. So by using AcoustiVibe, which is this system over here, which again, you'll see a video of it, AcoustiVibe is designed to be installed on the side of the joist and completely decouple the layers of drywall, which would be attached to the furring. So it will be decoupled from the drywall, from the rest of the structure, which means a vibration is not quite going to make it to the unit below. So when you combine these two things together, exactly what the drawing shows, we are currently shooting anywhere between high 50s to low mid 50s on the buildings. Example, in Victoria, we got a couple of our friends, developer out there that's done a few buildings, and every one of those buildings has shot, I believe I want to say 56-ish STC and 59 IIC or AIIC. They were sitting a lot lower than that before we showed up. So bottom line, this system, no one here is a guinea pig. There's been a lot of buildings done also out east. So when you're combining those two systems, you end up in a really good place. One other thing I want to also mention is we want people to use AcoustiVibe. The only time that we'd say AcoustiVibe is not a must is if somebody's working, for example, on a townhouse or working on a duplex where they were not using gypcrete concrete topping before, and they're used to putting the floor covering directly over top the plywood. So if you're not going from a concrete topping typical assembly, and you're already doing just the plywood substrate with the flooring, then using AcoustiBoard on its own is going to be a drastic improvement, both on STC and IIC. So what I'm going to do now is basically play the video of this particular those two products. And by the way, strips are also available, so you'll see in the video when it comes to underneath the party walls. So I'm gonna play the video, and with this platform, there's gonna be no sound. So don't play with your computer. It's normal that there's no sound. You should be able to see the video, but not necessarily hear it. So the last part of the video, when you see the installer using plywood, this is not necessary if you're doing a floated laminate floor or an engineered floated floor that's over 10 millimeter thick. Usually, if you're interested in that system, get in touch with me or get in touch with our team so we can look at the floor covering you're intending to use, and then we'll make sure that the compatibility is there. The only time you'll see somebody use Acoustiboard with plywood over top is if you're going to ceramic over top, and then you're not necessarily doing what I've mentioned earlier, or if you want to use any kind of other floor covering, but it's not quite typical that we see that. Now I want to make you listen to the Acoustify video, and then we'll do the same process. So this gives you guys a little bit of an idea. As you can see on the video, the screws come with the clips, and in a lot of cases, I can even tell you an example of, we're currently going to be working on an affordable housing job in Calgary, and then to some extent, the way this building was built was this typical resilient channel, and it was there was no topping over top. So when we analyzed the building structure, we were truthful. We said, here's what we think is going to do on the STC and IIC. And then ultimately, one of the systems they ended up picking, and the building's already up, one of the systems they ended up picking that will boost what they were currently at versus resilient channel with AcoustiVibe clips is going to give them at least probably anywhere between 6, 7, 8 IIC more than the resilient channel, which, by the way, often ends up not being installed properly. So the bottom line is AcoustiVibe versus resilient channel, night and day as far as efficiency, because all of a sudden you are decoupling that drywall assembly from the rest of the structure. So just to give you a little bit of an example to some extent on that front. If you are looking into this system, that's something that interests you, get in touch with us for available acoustic reports. We have a ton of data on it, whether it's in the lab or in the field in different territories. Fire report, just so you know, with the 2 layers of drywall, AcoustiBoard on its own does not require any fire rating as far as the report's concerned, because like I said, the ceiling structure with the plywood, OSB, whatever it may be, is going to give you 1 hour fire rating, but the AcoustiVibe does require it, and we do have it. So if you're looking into using this system, we'll provide you with whatever report you want. Now let's move into our second assembly. Fermacell. Fermacell is a product out of Europe, now a division of James Hardie. Fermacell, in a nutshell, is basically this panel here. So it's dry flooring element, recycled gypsum, paper fiber, and water. So basically all recycled content. It's 2 staggered panel, pre-attached to each other with a decoupling agent underneath of it. And the idea is basically creating a new subfloor. It is 1/8 of an inch thick. It weighs 5.3 pounds per square foot, so it's still substantially less weight than using concrete or gypcrete, and it comes in 2 by 4 feet panels, so 8 square feet. Screws and glues will come with the panel. In this case, because of its weight, because of how it's made, if you were using a concrete topping gypcrete before and you want to move to not using that, you are not obligated to use AcoustiVibe if you don't want to, because the panel on its own for flanking, IIC, STC is going to bring you exactly where you want to be, so you guys can see the data in the bottom depending on the floor covering. But if you are interested in doing a really good job, as an example, working with the Greater Victoria Housing Society, so I think some of them are actually on the call, so thank you. We're actually about to install 60,000 feet of Fermacell and AcoustiVibe on the island, and this is a Cascadia architect job, Kinetics. So again, we thank them. So we're very excited about that to happen. And obviously it goes without saying, Europe or even Eastern Canada have been using this system for years. So we're just introducing it the past couple of years out west, and we've already got a lot of people that not only are interested, but that we're on the specs. One other thing about Fermacell also is the advantage versus AcoustiBoard, AcoustiVibe is it's extremely permissive for the floor covering you want to use. So for example, because of its hard, smooth surface, you can use an LVT glued down. You can use an LVT floated with a mat. You can use ceramic tile. It also comes as a panel called 2E31, which is the same panel and 2E32, same thickness, but the 31 is designed for a ceramic tile, so slightly harder decoupler underneath. So very efficient. And then obviously, like I said, very permissive for whatever the floor covering is going to be. and then ultimately can be used with or without AcoustiVibe. So what I'm going to do here is I am going to also show you that Fermacell, should I say, can also be used in mass timber building. So depending if it's commercial, residential, we do have some requirements in our STC. But Fermacell does come also with a little bit of an add-on product called the honeycomb system that can be installed with an exposed CLT or DLT or glue lamp, whatever it may be. So Fermacell system has been used before on mass timber buildings, and it can achieve to some extent the ratings that I'm putting on the right side. So if you're interested in seeing reports for that, please let me know. So I'll play a quick video of the Fermacell, and that's the last video of the series here. So if we want to use Fermacell, for example, versus AcoustiBoard, AcoustiVibe, it's all about what you're trying to accomplish. So ultimately, when we consult together, when we work together, we'll be able to evaluate what's the floor covering you're going to choose. Sometimes it will dictate which of these options is better suited for you. And then obviously the budget, are you using AcoustiVibe or not? So to some extent it becomes, it's not confusing at all. By the time we answer a few simple questions, really, acoustic target, what's the floor covering gonna be? Do we have any elevation issues, weight? Once we start looking at all of these things together, ultimately it becomes quite clear which of the option is gonna be the best one for you. So it's kind of a little bit of a funnel process to some extent. Once again, if you want acoustic reports, we can provide that. Weight report, Fermacell has also done a weight report versus a concrete or gypcrete building. Super valuable. A lot of people have downloaded it and looked into it. It basically tells you how much collateral saving do you have when using a lighter system versus using the typical system. So it's going to help you on the engineering side of things. So it's not solely about acoustics. It's also, aside from the cost of the material itself, can we have other collateral savings and getting rid of the weight? Absolutely. Support beams, there's a lot of things to some extent that are going to be advantageous to use something that's much lighter. Fire report, same thing, not applicable of anything that's over top. The plywood, if you are using 2 layers of drywall, which is quite typical in Canada, and then we can provide the report for AcoustiVibe if AcoustiVibe is to be used. We're working with Fermacell and getting to some extent a document that will to some extent list the assemblies, whether they're MBC or ULC assemblies, to some extent that you could choose to use, that ultimately you're going to be able to use Fermacell over top or even AcoustiBoard over top. So we're working on that too. We're trying to make your job a whole lot easier where you don't have to do as much research. The last but not least, if somebody is interested in having the most soundproofed building on the block or in your town, there's one system that Acoustic Tech has designed a few years back that was technically positioned for mass timber buildings. So it still is, very much targeting the mass timber buildings, because mass timber buildings tend to be a little bit more problematic acoustically, especially because there's usually no ceiling. It doesn't change the fact that if somebody wants to do an unbelievable job with a lightwood frame building and get rid of the weight, well, the Soffix system would certainly be one of the options that you could evaluate. So a Soffix system is basically this panel here, and the Soffix is a dry flooring element. It weighs literally half a pound, per square foot. So it weighs half of nothing. The concept is the pucks over here, when the panel is installed over top the existing OSB or plywood, the only thing that's touching the plywood or OSB is the tip of those pucks. So the rest of the structure is free floating over top of that, which obviously means there's less room for transfer physically between what's happening on top and what's happening underneath. So what you end up with is a 1.5 inch thick panel, weighs half a pound. Those panels are also 2x4. And then you can or cannot use AcoustiVibe. It's up to you. Once again, because you have two staggered plywood or OSB, whether it's 5/8 plus 1.5 inch for all flooring. If you're doing ceramic, we suggest to go 5/8, 5/8. So it is somewhat of a labor-intensive process, no doubt about that. But it doesn't change the fact that acoustically speaking, if you look at the ratings in the bottom, it will most likely, depending on the floor covering, it will most likely bring you in the mid 60s. So at least low to mid 60s on IIC, same with the STC. So we don't want to discard the fact that some people out there, and I know some of you that we've worked with, that are trying to just do an incredible job, because you can turn your building and you can, make a claim to the potential buyers that you're taking acoustic very seriously. So not to say that this is for necessarily everyone, but just know that you do have that option. It is available. I don't have a video for that one. If you want more information on it, I can certainly forward that, or we can forward that as a team. This is also available if you want to use it on mass timber. As a matter of fact, we're spec'd on a few jobs with mass timber, where mass timber, like I said earlier, does not necessarily have a ceiling. The slab itself is often a little bit more problematic for flanking because it's a little bit lighter than concrete. So some people that are doing 6-story or less mass timber buildings, or even hybrid system with a topping, Soundproofing can do an incredible job, because the only opportunity you've got is to do it from the top. So bottom line is you're once again decoupling that floor covering assembly from the structure, which ultimately means that you're going to have less impact transfer while still being in a really good place for the STC. In this case, we can even add one of the AcoustiTECH underlay underneath, which means that the pucks, instead of being directly in contact with a hard surface like the CLT or glue lam or DLT or whatever it may be, or even plywood, can add a few points on the IIC. So the ratings I showed you before could even be boosted up more by using a needle punch technology product underneath. All comes down to where do you want to be, and then how much money are you willing to spend, and then ultimately what your objectives are. It's not AcoustiTECH choosing, it's us giving you options, what works for you, and what are you trying to achieve, and guide you in the most honest way. So this is what we're all about. Same thing if you want a report on Soundproofing, whether it's acoustically or if, once again, on the fire report, it's the same exact gig than the other two products that are designed to be installed over top the subfloor. But we're also going to work on giving you a list to some extent on ULC or NBC assemblies. Takeaways, so we're right on time. What it comes down to is, if you surround yourself with the right people, there's no room and there's no more reason for frustration, whether it's acoustic complaints or lawsuits, whether it's you don't want your building to have a bad rep, or you don't want to all of a sudden be competing against a concrete building, and you want the acoustic to be a little bit of a concern. So we can guide you through this, or if all of a sudden you all to some extent confused on all the systems and all the opportunities. We're not a product-oriented company. We're an assembly-oriented company, and that's what makes the whole difference. Is we're not isolating or biased to one thing over another. It's all about what rating do you want to achieve and what parameters are you after, and then ultimately we can customize and design things with you. The other side of that too is innovative options are now available. So remember what I said at the beginning. I talked about it's not because we've been doing things for 30 years that we necessarily need to keep doing things the same way. I'm personally and my company 100% okay with people doing whatever they want. But at the end of the day, our responsibility as an acoustic-driven company is to put options in front of you. And then all of a sudden, you end up with a variety of choices to some extent that will bring you some added value or not. So to some extent, it's entirely your choice. Dry topping solution for all floor coverings, acoustic target budget. Once again, we don't choose the floor covering. We guide you through, here's what's going to happen if you use this floor covering. Is that really what you want? Yes, great. And then we're going to adjust and bring you the option that applies to that. But we're gonna, I would say challenge you, but we will bring you data. We will bring you information on all the decisions that you're making and work with you with your best interest at heart in order to all of a sudden end up with a solution and the assembly that's going to be the right one for you. So, and that being said, that's why we basically call it our custom process and guidance. We also have a recipe book that includes all types of structures. So AcoustiTECH put together a recipe book. So if any of you are interested in that, please shoot me an email, let me know, call me, text me, whichever, and then or AcoustiTECH head office, and then we'll basically forward you any documentation that you are in need of. One quick little note, Suprema also does a product on plumbing. Just so you know, there's no other way to say this. There's nothing more stupid in a building to deal with an acoustic, complaint because people can hear people flushing upstairs or side to side. So Suprema Acoustic Drain is an amazing product that will even avoid you from having to go to cast iron, where you could just wrap the pipes made of PVC, and you're going to end up in a heck of a better place when it comes to the acoustics for your pipes. The process, I've already touched on that enough. I want to take 5 minutes to look at questions, but ultimately, the way it works is simple. You're interested in working with us, you're interested in knowing what your options are. There's no cost whatsoever for you to do that, whether you're a property manager, whether you're a condo board or strata, whether you're an architect, a developer, a flooring manufacturer, a flooring dealer, or any kind of, or GC or anything in between. Ultimately, we're here to ask you questions, for you to tell us what you're trying to do, and then basically we'll put some options and recommendations in front of you, and ultimately you have the liberty to choose to listen to us or not. So it's completely up to you. So far, very excited about the relationship we've built with local people, and I can tell you right now that I'm still to see one developer, one architect, one GC that's worked with us that was disappointed in the outcome. At the end of the day, once again, the idea is to get rid of the frustration and make your job a whole lot easier. So I've touched on that to some extent. So what I would like to do to conclude, for those of you that want to stay on, please do. I'm going to go to question for 5 minutes. Bear with me, I haven't done it, but I'll try to figure it out. So I'll try to answer it. It's still recorded until I press the end button. So if you need to go, great. If not, stay on and I'll answer some of the questions. So here we go. So that's a good question. What about WPC or SPC flooring? So I talked about vinyl flooring. One quick thing, I did a presentation with the NFCA, National Floor Covering Association, a few weeks back. The WPC, SPC, we're putting that in the same category of vinyl flooring. So they're usually a little bit less permissive on mechanical stability to some extent, for the joints not to crack. So it's certainly suitable to go over top of Fermacell system, no doubt about that, but not Acoustiboard. Unless it would be a product that I've not seen that's a lot thicker, where there is to some extent, a WPC or SPC surface, but there's a big core, then we could look at it. So I would still say, don't make a decision on which system is good for you unless you talk to me, or talk to my team, depending where you're situated. One quick thing I want to add on vinyl floors. Vinyl floors are great. Be cautious with the cork or foam backing. It's great, but be careful with the numbers that sometimes will come out of these assemblies, or at least of the manufacturers out there. Some of them are very well intentioned, some of them are not as well intentioned. You got to keep in mind that doing a cord back or foam backed SPC or WPC or vinyl plank, vinyl plank or vinyl tile doesn't change the fact that if it's on a concrete slab, that's one thing. If you're on Fermacell, that's another. If you're in a wood frame building, you're going to get something different. So everything I said about each component cannot be isolated within a rating, applies to every component, including the flooring. So to some extent, if you tell us a little bit what you're working with, what the brand is, we can certainly guide you through this. Can you install carpet over the AcoustiBoard? Absolutely. You can install, but broadloom carpet. So meaning you cannot do carpet tile over top AcoustiBoard, because carpet tile will require most of the time a pressure sensitive adhesive. And if you looked at the fabric on top, if you use pressure sensitive adhesive, which in a nutshell acts as a Velcro, well, you're gonna have no glue left, which means you're gonna have no adherence for your tile. So two things: either you don't use carpet tile and you use broadloom carpet, which would be installed the same way with your strips as you would normally, or you can go to a Fermacell system, which will be welcoming a carpet tile. So it's one of the two. Actually, there's one more option. You could do like the video was showing. You could technically use AcoustiBoard, cover it with plywood, then ultimately you can do your pressure sensitive and carpet tile. So if I did not fully answer that question or any other question that's coming my way, please don't hesitate to call us, and then we'll look into it. So cool, Vincent said that the sound worked in the video. Wow, that's great to hear. How do these compare to Suprema Silentcrete, Sinus, and had 60 rating? Well, technically Silentcrete, give me 1 second here. Yeah, it's a little bit of a technical question, but Suprema has other underlays that go underneath the concrete topping and this and that. So if, for example, we're trying to compare what would AcoustiBoard AcoustiVibe, what would Fermacell alone and Fermacell would AcoustiVibe, or what would Sofix and Sofix with and without AcoustiVibe. So there's really 5 options. If you want to compare this on performance, cost, weight, and everything else versus the typical assembly, we do this every day. So every component within that analysis is important. So if you have an interest in anything I just shared and you want to compare it to something you were doing before, it all comes down to getting in touch with us, saying, here's what I'm thinking, here's what I was doing before, how does it stack up on efficiency, STC, IIC, cost, and everything else. So we can do cost analysis side by side, and I'll tell you exactly how it stacks up. So again, what you choose underneath the concrete topping, what it is, what's the floor, all these things need to be addressed in order to answer any question on that front. Does your experience with sub-trade or trade contractor in installing the materials? Good, that's a really good question. To some extent, so the experience, no doubt on the island, as an example, AcoustiVibe, we've done a bunch of buildings already, so we know for a fact, or I shouldn't say only on the island, I mean, we've done a bunch of buildings really out west. So there's a bunch of drywall contractors that got very, to some extent, very familiar with using AcoustiVibe. There's also some systems out there they were familiar with, but by the time we get in touch with them, we tell them what to do, we show them the video, and it's not rocket science, it's pretty straightforward. AcoustiBoard is as easy as it's gonna get, because ultimately you're floating a board on the floor, so it may as well be the same thing as installing plywood. But we also work with the local contractors, Colin, as far as making sure they know how to install Fermacell, they know how to install AcoustiBoard, or they would know how to install Sofix. So in a nutshell, we're not isolating or neglecting the importance of being in touch with the local trades and not putting all our eggs in the same basket on the spec side with the builders and the architects. So it's a really good question, but it's very important for us to be present with the people locally. As a matter of fact, as soon as the Fermacell job on the island starts and everything's safe for me to go to the island, I will go to the island, spend time with the flooring contractor installing Fermacell to make sure the guys are somewhat familiar with it and show some support. So very important. And that's aside from installation is a big part of the efficiency of the assembly to start with. So as you can see, we're trying to basically do the whole loop. We're guiding, we're consulting, we're working with you. We then identify what the right assembly is. We then work with the architects and builder to make sure the specs are according to what we're trying to do. And then the sub-trades are involved within the bidding process. I am personally, or my colleagues are personally involved with that bidding process on all the products I showed you to make sure people are paying the right thing. that the logistics behind it is also taken care of. And then once it's ready to be installed, shipped and installed, we're also there. So being a Canadian company, we are able to basically get everybody on the same page. There's no missing link anywhere. No one is trying to figure it out on their own. So that kind of concludes to some extent. If there's anybody interested in pursuing this, into investigating on this, we're currently doing it a lot. I have a great team behind me to back us up on technical side, on sales side, and would be more than happy to hear from you. So if there's any questions or requests for documentation of any kind, please ryu@acoustictech.com. So I'm not sure if, bear with me, I'm not sure if you can see it here. So again, ryu, A-R-I-O-U-X @AcoustiTECH, as you see it on the screen. .com. Shoot me an email, and if you're not in Western Canada, shoot me an email anyways. I'll put you in touch with the right people. So on this, 2 minutes past the hour. Thank you so much for attending this webinar. Always have a blast doing these things. Hopefully you got some valuable information. Look forward to being in touch with you, and then stay safe out there and enjoy your summer. Thank you.